Okay.
So next, we're going to be doing an introduction to JPSS data and products and their scientific maturity. Lihang Zhou, who will be presenting. Lihang has over 12 years working with NOAA on the GOSAR program, the NOAA Integrated Program Office, and the Center for Satellite Applications and Research, or affectionately known as STAR. Her primary responsibilities are STAR JPSS Program Manager and Science Deputy for the Algorithm Management Project. Welcome, Lihang.
Thank you, Christy. So Mitch and Dan give a really, sorry. So it's really nice to follow Mitch and Dan's talk. So you see, the JPSS is really critical to all those application, but the high quality data product and observation is really the foundation of all those applications. So I'm very glad to be here to give an introduction to the JPSS data product and their scientific maturity for both SMPP and NOAA 20. Okay, so I'm going to first give a quick introduction of the data product and CalWOW, and then I'm going to talk about the data product scientific maturity, both SMPP and NOAA 20, our plan, and some of the CalWOW updates, and also time allow, I will also introduce the reprocessing status and give a summary. So some basic terminology you will hear when people talk about JPSS data product. The raw data record is RDR is equivalent to those level 0 data, refer to the raw data generated by sensors on the satellite. And then after the science algorithm perform the calibration geolocation, it generate from the RDR, then it generate the sensor data records. And then we apply the geophysical parameter retrieval algorithm, and then get the environment data record called EDR. And those are, like the various imagery, atmosphere product, and land product, ocean product, and the cryosphere products, etc. And we are not only retrieval product from JPSS, but also other satellite platforms. So lots of user, for the user's application, we also generate blended product that's combine the information we got from JPSS and other satellite sensors, such as the AMSR and from the GCOM and other satellites. So this is array of JPSS instrument products. As Mitch mentioned, that now we just have JPSS 1 launched. Then we are going to have a JPSS 2, JPSS 3, 4, each at least 5 years. So we are considering more than 20 years data product and high quality measurements from JPSS program. And for students to take a note of the website, at least here, so it have all the algorithm theoretic documents and other CalWOW document for the JPSS products for all this sensor and instrument and environment data product. So if you want to do more homework, read those after today's the training. You can. So for all this product, to ensure that we have a high quality and meet users' requirement, we have our JPSS STAR CalWOW program. We do 4 phases of the CalWOW. Start from pre-launch, we do the sensor testing, data analysis, algorithm characterization, and the validation preparation. And then early Albedo checkout, the first 90 days, we do the sensor calibration, system calibration fine-tuning, and update the initial lookup table using the on-orbit data. And then we go to the intensive CalWOW phase. We do the intensive CalWOW of all the XDR data products. and then make sure that meet the requirement and reach the validated status. And then after that, we do the long-term monitoring and science maintenance all the way to the sensor life cycle. We use standard measurements, beta provisional and validated to measurement the maturity of our science product. When it's called validated, we said all the data products are very well characterized and meet users' requirement. So this is one snapshot tell you how well we do for the SMPP data product. So all the data product listed here, including SDR and EDR, are most of them are validated, so meet the user requirement. From the launch of the SMPP, October 2011, then we first have our all the sensor data record reached the beta status in April 2012, and then soon after that, even in the beta, the VIRs and ATMS got used operationally by the NWP centers. And then April 2013, that's like 16 months later after launch, all the SDR declared provisional and ready for operational use. And after that, all the sensor data records from SMPP has been used by our national and international centers and in their operation. That's for the SMPP, and how are we going to do for NOAA 20? So this is a timeline for our CalVal plan for NOAA 20. You can see we have a much more accelerated timeline. So by launch plus 90 days, all the key performance parameters, including ATMS, CRIS, and VIRs, all the SDRs and imagery, we have reached the provisional. That means ready for operational use. So we are in the middle of this 90-day period, and so far we're really doing pretty good. So I'm going to bring you some of the updates in my following charts. So I actually looked at the attendees list from Gary yesterday. It looks like most of you have already pretty familiar with JPSS. So I'm really during my talk bringing more update and improvement we will have for the NOAA 20. This is an initial look for the ATMS. ATMS is really a most critical sensor for the weather forecast. From the initial CalVal results showing that the NOAA 20 ATMS performance really well. The scan drive show no normal condition, so we won't see those. The SMPP, we have some scan motor drive issue, and also the good news is the noise is very stable, and you can see the charts on the lower compared with SMPP, the noise is lower than the SMPP for all the channels, and also the striping is also lower than the SMPP. And the channel correlation is also lower than SMPP. So all those are very good news for our NWP users. We actually just had our provisional review, including our users, and so we think it's ready for operational use at this point. The ATMS data product. So with ATMS measurements, it's very useful for the hurricane, so you could detect the warm core, not only the size of it, but also where it's located vertically. And this is showing the cross-section of the ATMS vertical temperature. You can see how each layer, the hurricane structure changes, and also how the cross distribution of the hurricane structure. This is similarly, you see the Hurricane Isaac, the warm core characterized by 2K anomaly temperature. So it just gives you lots of details how the temperature structure for the hurricane events. Moving on to the CRIS, the hyperspectral instrument. So what's new for the CRIS instrument is that for NOAA 20, we're going to start from full spectral resolution from the beginning. So we already generated CRIS SDR full spectral. That's more than 2,000 channels for each of the observation. We already actually just got our first light yesterday. The global coverage looks really good, very much comparable with what you see here from SNPP. We just wait for the public release to push it out. So with the CRIS instrument observation, as Mitch mentioned in his talk, it's going to make a really important impact in the weather forecast. And this is showing here, so with a normal resolution CRIS observation, it's about 9th how important among other sensors. But with a full spectral resolution using 20 more channels, this is from Jim Zhuang's experiment, is showing that it's raised CRIS from 9th to 5th, so significant improvement, the utility of the CRIS data in the forecast. So CRIS is so from the initial results, CRIS data looks really good. We are expecting to meet the provisional maturity launch plus 90 days. And with the CRIS combining with the ATMS, we are going to get improved humidity information. You can see the bottom is a combined, the top is ATMS only, bottom is combined with the CRIS. You can see more structure of the humidity. And also thanks for the PGRR, the retrieved temperature moisture already available in the AWIFs to the weather forecast users that you will hear more later today. So with a full spectral resolution, in addition of temperature moisture, we can also retrieve the carbon monoxide, carbon dioxide, and methane. This is example. You know that North California Santa Rosa fire earlier, like 2 months ago, you could see that from airs, and now with the full spectral resolution, you could also see from JPSS. You can see compare with airs because we have a wider coverage. You can also have a better coverage of the carbon monoxide retrieval. And in addition of the horizontal distribution, the CRIS will also provide the vertical distribution. So just a lot of capability for the environment monitoring from CRIS instrument. Now move on to the VIIRS, the advanced imager. So the NOAA 20 already we got very good data. This is a fire. This is the first image. You can see the fire from the California, and also the data band that Mitch showed. The quality is already very good. There's some known issue of the geolocation, and we just got the lookup table updated, implemented yesterday. So the geolocation looks really improved already, and we are expecting that our VIIRS SDR also meet the provisional maturity launch plus 90 days. So from VIIRS, we generate many environment data products. I want to start with one of the high priority product, the sea surface temperature. The sea surface temperature product generated by NOAA Enterprise Advanced Clear Sky Processor for Ocean, the Expo. We call it NOAA Enterprise SST algorithm. So when we say it's enterprise algorithm, it does not only run work for one sensor, but it works for multiple sensors. like this one, Expo work for SNPP and JPSS VIIRS, and also GOES 16. You could see another sensor. You could see the side by side. This is GO16 SST retrieval compared with the VIIRS SST composite. You can see they are very much comparable, but VIIRS, of course, reach to the polar region, and because of higher resolution, you can see more finer structure of the sea surface temperature. For the SNPP, is very well validated. The performance, as you can see from the table, both the accuracy and precision meet the requirement with a wide margin. Since sea surface temperature is a very critical climate indicator, so the long-term stability of this data record is very important. So we already use the advanced algorithm, matured algorithm, to do the reprocessing of the whole data record. So the reprocessing for the SST is actually available for SNPP. And so the SST validation is still ongoing. So you can see this is from the beginning of the mission all the way, very stable performance, very high accuracy and precision within the requirement. You do see that early in the mission, you have a little bit more bias and standard deviation. That's exactly why we have to do the reprocessing. So when we do the reprocessing, it's going to be more consistent data record with very good, very high accuracy and precision. So we have multiple data monitoring tools there for SST. You can go there to see more information for the performance of the sea surface temperature. We also have an ocean color data product generated. So it's a heritage at NASA algorithm, but we already done lots of major improvement, such as inland and coastal improvement, and also destriping, and improved aerosol cloud and ice detection and correction. It's also enterprise algorithm means running not just on CVIFs, MODIS, and also VIIRS. So multiple sensors. The data already validated for SNPP and meet all the requirement, and has been already reprocessed. As you can see, this beautiful charts there showing the 5-year climatology retrieved from the SNPP. It's also have lots of important application for the fishery and for the environment monitoring. So the reef managers are using our ocean color to monitoring the ecosystem environment. This is an example of the Puerto Rico, and there's much more application than this. Just showing here the ocean color from NOAA 20 looks good, as Mitch mentioned. Since it's ocean products, it's really very sensitive to the sensor, so we call it a canary parameter. So we always want to first look those ocean products to see how they perform to tell us the sensor if it's performance expected. So the ocean color really performance pretty good from the initial look. And for all the ocean product, we have this NOAA Coast Watch, Ocean Watch, distribute all the data product to our end user, so including ocean color, SST, and also surface wind, the ocean heat content, which is derived from the SST, but also using the altimeter data. It's really tell you how intense the hurricane is, and you probably will hear later today. So if you're interested in ocean data product, go to our Ocean Watch portal. You could list it here. And now we'll move to the land products. So we also generate a long list of the land product from JPSS. The good news is that all the SNPP land product have been declared validated, and we also have a GCOM land product. Soil moisture is also validated October last year, and you can find more information on our website. All the SNPP and JPSS operational product are now transitioned to ESPC generated by NDE going enterprise algorithms. And we believe that best quality data record need reprocess using the NDE Enterprise algorithms. So this is the Enterprise surface reflectance results. So this 375 meter resolution is really a foundation of many of other downstream land EDR product. This is a gridded vegetation product, including the vegetation fraction and vegetation index. It goes 4 kilometer global grid and 1 kilometer regional. Very high resolution, very high accuracy precision products. And we also have land surface albedo. It's also now generated gap filled, noise reduced, and gridded land surface albedo more fit to our modeler users' need. As you can see, the panel above is the granular albedo. You see lots of gaps, and the example in the lower panel showing that our new gap filled and noise reduced surface albedo, which is more user friendly. That land surface temperature, right now we are transitioning the land surface temperature enterprise algorithm, which is based on the surface emissivity, which better accuracy than the legacy algorithms. Right now we are transitioning the granular-based algorithm to the operation, and we are also developing a gridded algorithm product for our NWP users' need. Very popular various EDR product is Active Fire. This example, you see that the North California fire, the fire power tell you how intense the fire is. In addition of the M-band 750 meter fire product, we are also developing I-band fire, which give you higher resolution, 375 meter. And both products will deliver the fire mask and also the fire radiated power. Fire radiated power actually used in air quality and smoke analysis and prediction system like the HRR model, and also it's in AWIPS too. I'm showing here the new JSTAR mapper we are developing. Quickly show you more JPSS product. In addition to the fire, you could also see the aerosol optical depths and also the dust and the smoke generated by those fire. The soil moisture product, operational product system, SMAS, is really a very good example of the blended product. So for the JPSS, we generate soil moisture product from the GCOM AMSA2, which is the Japanese satellite, but we combine that information with SMAS and ASCAT and blend it into the SMAPS data, and that's ingested to the NWP models for their forecast. We also have the cryosphere, snow, ice, and polar wind EDR product listed here. Just quickly update, all the product meet the requirement, and all the product are operational, and we are planning to run the J1 algorithm to generate all these products. Just want to show you the day-night band from the weather bomb just happened 2 days ago. So you can see clearly here the snow on the ground all the way to the Georgia. And if you look closer, you probably can also see some of the traces of the snow in Florida. That's the first time 30 years I see snow in Tallahassee. And you can see also the circulation, the wave, and also there's the light strike over the Puerto Rico region. So lots of information provided by our various day-night band imagery. And just want to give you a heads up, we have this Snowfall Rate product also performed really well. You see the Snowfall Rate over the northeast U.S. This is actually the proving ground product, but we are transitioning that also to the operation. Just couldn't help to show you some of the NOAA 20. This is a thermal band M15 imagery from NOAA 20. You can see all the cloud structures of this weather bomb storm. So just amazing features. And this is a global image from NOAA 20, the M15. You can see it's a very well also capture the big structure of the storm. So very exciting time. So this is a carve-out plan we put together for NOAA 20, including all the SDR EDRs. So much faster than the SMPP. And talk about enterprise data product. Almost all the data products are now running in the NDE in enterprise data generated enterprise data product. Only a handful of them which will be in operation in a few months. So lots of good progress of the SMPP and Calval and NOAA 20. So all the SMPP products are reached validated maturity, are currently in long-term monitoring, and validation results suggest that SMPP EDR data product in general is accuracy similar to the existing product. And we are replacing and upgrading the current SMPP algorithm with the NOAA Enterprise algorithm almost finished off, and demonstrate the pre-operational evaluate JPSS1 sense data product algorithm mitigating the J1 instrument waiver and new algorithm for J1 instrument upgrades. So all the NOAA 20 algorithm seems already working pretty well for the SMPP, for the KPPs, and with improved knowledge of the pre-launch characterization, the J1 instrument, and leveraging our lessons learned for SMPP, our carve-out activity for JPSS1 will be much faster than the SMPP. And that's it. Thank you.
Thank you, Lihang.
Oh, I have 2 minutes, so I have a bonus actually. If I may, I would like to show you. I just want to deliver the message from our science team to you all here. It's a small movie.
That's a microwave sensor.
Microwave data is cloud penetrating, which is one of the real strengths of using microwave data.
And so therefore that's what we call the all-weather sensor.
The CRIS radiance can be used directly in the numerical weather prediction. For NWP in models, second most important impact for weather prediction as far as satellite data is concerned.
Surface type is one of the primary variables impacting the land surface and atmosphere energy fluxes. Weather is impacted by energy. Energy will impact the atmosphere motion, will impact weather and the climate.
So NOAA is the only agency to generate that product, the surface type
The
product.
layer which we see from satellite is approximately 10 micrometer depth. This layer is responsible for the exchange of the heat between ocean and atmosphere. SST is, for instance, very important for hurricane development.
You are just start thinking about the job. Of course, this is very promising. But there will be a lot of data you need to. You can really, I said, unprecedented, exciting time to do remote sensing for ocean color particularly.
Yeah, by the way, I actually was able to see the launch site lights from the VS day-night band, like 20 minutes before launch.
Wow.
That's fantastic.
All right, thank you all.
Thank you.